this talk, I'm just going to switch to data. I'm a data person, I'm not a computation person, as many of you know. I want to go over some of the data issues that we're going through at NCI as we build a fairly substantial 10 petabyte publicly accessible data store at the NCI funded in part by RDS. So I just want to calibrate the audience because as Ben was talking, it was exabyte and petabytes, but as you saw from his slides, he was definitely emphasising that we're not totally in this realm. A lot of trouble with people who switch off because, I'm only dealing with megabytes and gigabytes, whatever you're talking about is irrelevant. At NCI, we do try very hard to scale down. We build for the big systems and then scale down. To me, there's a growing data problem which is really starting to emerge as we move into big data, which a lot of people kind of don't realise. And the key message is that we've currently got 4 zettabytes in 2013, and we're going to have 96 in 2022. And already people are saying that we will not be able to manufacture the storage for the data that our new instruments that can now collect data at higher resolution and much faster speeds can get. And so the funders, when you talk to them, are actually starting to think about it, and I guess a couple of us started to raise another problem which is really emerging. And I will take you through what this problem is and why we need to have greater community collaboration in how we actually develop these high-performance data sets to be used for next-generation research. So the government funded 8 data storage infrastructure nodes around the country. You may or may not realise that there is now 49.3 petabytes sitting on these 8 nodes. At NCI we have 10 petabytes. Aussie is focused more on the square kilometre array, so it's more astronomy. But NCI's focus is on earth and environmental sciences. Once the infrastructure had been set up, the RDSI infrastructure project morphed into research data services, and they set up 9 domains or themes. And you can see that NCI is the lead in the Earth systems, which is geodetic, bathymetry, Earth observation and climate, and topography. We're involved in the astronomy, we're involved in this one at Pawsey, but we are the lead in actually starting to sort out the geophysical data that we have on the NCI node. And based on what was said yesterday, I will also add that every program had to have an industry engagement program for what it was going to do. The goal of the RDS program is that researchers are able to share and use significant collections of data that were previously unavailable or difficult to access, and researchers will be able to get at them in a general interface and a discipline specific. And it's the discipline specific that is starting to cause a fair amount of grief. The important point is, as I said, I don't know how many of you knew, or hands up, how many of you knew that there's now 49.3 petabytes of publicly available government and research data on this infrastructure? Yeah, 2 people. NCI kind of took a different tack in that each node had its own specialty, but what NCI did was, because it was attached to a hunky great supercomputer and a fairly substantial node cloud, it said that it was going to specialise in data collections that required high-performance computing and data-intensive capabilities for use in effective research methods, and that the synergies were going to be related to the other e-research programs that are around the country. We had this beautiful letter of support from Chris Bygram, the CEO, where he nailed it, in which he said that there will be agreed standards to enable interoperability between the partners, and the partners are CSIRO, GA, ANU, and Bureau of Meteorology and other universities. So this is what we were talking about yesterday. This is government and research on the same. And what it said was that GA would work within the partnership rather than saying, here's the GA data here in this file and this is how we will make it accessible, and we don't really care what everybody else is doing with their LiDAR data. The idea was that if it's LiDAR data or if it's Bayesian data, it can be accessed across the whole gamut. So the general support process, as I said, we took data from universities, government, non-government organisations, and we curated the data and we complied with things like the ISO 19115 metadata standard used by government, as well as the research metadata standard promoted by AMSI. So basically we're getting this general purpose access, and if you go into the AMSI catalogue or the NCI catalogue, the data are all there, referenceable and ready for your access. So coming back to NCI with its domain data, we were supported by the RDSI funds to build a 10 petabyte plus national environmental research collection. Again, I emphasise it was government, research and international groups, and you can see how we're going the whole gamut from astronomy right down to geophysics at the centre of the Earth. The data are located with a rather big supercomputer, a cloud, and we have virtual desktop interfaces and digital laboratories which enable small users to access. We actively encourage people to access the data in situ via services, otherwise we're just going to become one God almighty FTP site. The really important thing that I want to say here is that processing times have decreased dramatically. New data sets can be generated or analysed in minutes or hours instead of months and years. And what we're now starting to find is the growth of this concept of analysis-ready data, where some person does a particular calibration or correction and then wants you to store that as the national version of that data, and when it's say 300 terabytes and you get about 4 or 5 requests of this, you realise what the problem is. This is what I'm trying to say, that we're worrying about the data, that we are growing the data faster than we can build the storage for it, but at the same time we're creating too many copies of the same data with slight variations, and then you ask, are these realistic? So now I want to focus on geophysics, and again we had a lot of fun. I was here in GA at the time, and immediately the guys went berserk and were doing inversion models in faster time, at much higher resolution and in quicker times. It was really fantastic to see all this happen, and so we started to work on that. But it's actually now time to move on. And so with the help of GA, we did an analysis of the actual data itself. And what we realised, and we've been hearing a lot about this, about, now we're on the big parallel systems, we've got to change our fundamental way of our algorithms and our programs, we've also got to change the way you're doing your data. And so what we actually found in studying it was that the geophysicists were kind of gridding the survey, then gridding the areas, and then gridding the national coverages. And so what we were doing was creating grids of the grids of the grids, which meant we were losing data, etc., as we carried on. And so then we started to introduce the term of HPD, high performance data formats, where you could actually get at this data at full resolution and start to look at some of these surveys, not just in lines, but in the actual points. We have the computer power to do this now, but how we actually get it to come together is going to require a lot of thinking, and not just by ourselves. We have to collaborate to do this. So let me talk about some work that we've been looking at. Now, if you're a patrolling geologist, they talk non-stop about the Segway format. And if you tell them there's something wrong with the Segway format, that it's old-fashioned, it doesn't work, it's not self-describing, and yeah, you can look at it survey by survey, but don't try to put more surveys together, they do tend to get a little bit upset. But there's like this massive global skunk works where this is just one thing I pulled off one website, and I can compile a lot, which is actually saying, hey guys, we're going to get realistic and start to use seismic reflection data in the new world with the new facilities. We've got to really think about this format and what are we doing to it. Another example is the passive seismic, and we have now found there's the adaptable seismic data format and the Pascal PH5 format, both of which are HDF, but there are subtle differences. And so are those differences for real because they've been developing them in isolation of other universities, or if we set up a global collaboration, we actually start to come together with a compromise and a community standard. So this is actually it's a bit overwhelming, but what we're actually saying is what we were funded to build with both the partner funding and RDS. So in our upper layer we have all our virtual laboratories. You have the likes of Dale and Marshall who just go straight in, don't want about any of these interfaces. And then we've got the portals to help you find the data. But what we have here is a platform where, rather than what is happening where some group just wanted to have the disk, have the space and go straight down vertical, we're actually saying, well, you know, how you're doing your web services is the same as that, it's the same as that, why don't we collaborate and work it together? And so we're starting to look at these old-fashioned formats and working out whether we should be starting to move into the more modern self-describing HDF formats. And that's a work in progress, and certainly with the geophysics we're doing that in collaboration with Geoscience Australia and also the IRIS Seismic Centre in Washington. So if I can make my things simpler, what I'm actually saying is we have all these virtual laboratories that enable you to access the compute and the storage. They actually like online environments. We have the portals that enable you to find the data. And then down here we have the infrastructure that I talked about, including the 8 RDS nodes, the compute that Lindsay talked about on Tuesday. And what we're actually starting to realise now is the missing component is a registry of software that can work in these parallel environments in visualisation and connect to the actual data in its standard formats. And my argument is that this is the stuff that's going to last the time. And we'll make this last longer if perhaps we can get the community to work not just within Australia, but to go and work out and see what's going on in the international, because this is really difficult stuff to do. And the more engagement you get and agreement on the standard, then my wish is that within the wonderful new community that's taking up computer science in the research community, you will start to develop the online open source programs that we so desperately need, because many of the commercial software will not work in the highly parallelized environments that we now have. So in conclusion, this is the point I was trying to make yesterday, and I was a bit disappointed that it didn't quite get across the way I intended to. But this is what the government has invested in computational infrastructure to support Australian research. When you talk to the government agencies, they're modernising on commodity IT. Oh, we're going to put our data on Amazon, we're going to put our data on Amazon. And they're not looking at the collaborative activities that are going on literally across the road, where we're building these shared platforms of government and research data. Many academic communities, when I talk to them, are unaware except for the niche researchers, and they don't tend to say much about it because they're having fun. They've got complete control of it and they're going, you know, they're really enjoying it. But again, some of the academic departments are not seeing these collaborative issues that have actually been built and funded in a program from the government that probably started in 2006. I would argue, because some of you know I spend a lot of my time up in the air, no other country has such an incredible resource for upskilling and connecting the next generation of data-intensive computational scientists and the ability to start addressing those grand scientific challenges, because the data is now exposed and it's available. But my final message is really that we need deeper skills engagement that improves the community-driven research platforms that are built as part of international collaborations to create these community-accepted formats and procedures. Thank you.